Hey everyone! Today we are going to continue our exploration of solving rational equations. Let's review our guidelines for solving a rational equation. The first step is to factor denominators and/or simplify each fraction. Notice in our first example here, we could factor the numerator. However, if we do that, we just end up with a 2 times k minus 6. And that doesn't help us to simplify with the k minus 3 in the denominator. So I choose to leave the rational expressions as is. The next step is to identify the least common denominator. In this case, our least common denominator is equal to k minus 3. Again, this is because we have a k minus 3 in our first denominator, a k minus 3 in our second denominator, and when we have an integer or a non-fraction expression, it can be written as a fraction expression over 1. Based on these three denominators, our least common denominator is k minus 3. So we need to obtain that by multiplying the top and the bottom of this right side of the equation by k minus 3. Now that we have obtained a common denominator, we can eliminate the denominators. So I'll cancel my k minus 3 in every fraction in the denominator. Our resulting equation will be 2k minus 12 plus 1 equals 5 times k minus 3. Now, let's solve our resulting equation. We'll combine like terms. On the left side, 2k minus 11 set equal to, distributing the 5 through, I have 5k minus 15. Now, let's bring our variable terms to one side. I'll subtract 5k from both sides, and I'll add 11 to both sides. The 11's cancel on the left, the variables cancel on the right. Then we are left with negative 3k set equal to negative 4. Dividing both sides by negative 3, we get that k is equal to positive 4/3. Let's verify that this in fact works. For the sake of time, I have plugged 4/3 in for k in my equation on the left side. As a result, simplifying my fractions on the left, and then combining my fractions, I end up with negative 25 over negative 5, which simplifies to 5. Therefore, k equals 4/3 does in fact work. Now let's take a look at the next example. Let's factor our denominators here. Notice that we have a binomial of the form x squared minus 4, x squared minus 4. We know that this represents the difference of two squares. So our factoring pattern for that type will be an x plus 2 times an x minus 2. And this denominator will be x plus 2 times an x minus 2. That's the new factor denominator. Now our goal is to identify the least common denominator. Looking at this denominator, it's missing a factor of an x minus 2 that I have over here. Therefore, if I multiply the x plus 2 by the x minus 2, I will have a common denominator. Therefore, the least common denominator is equal to x plus 2 times x minus 2. So let's go ahead and multiply the top and the bottom of our first fraction by x minus 2. What we've done here is we created fractions with like denominators. Therefore, we can cancel these denominators. That denominator, and that denominator. Our resulting equation will then be x minus 2 plus 1 equals 5. Let's solve this resulting equation. Negative 2 plus 1 gets me a negative 1 set equal to 5. Then we'll add a 1 to both sides. Therefore, my value of x is equal to 6. Let's verify this. Again, for the sake of time, I've plugged x equals 6 into my equation. So every single time we see x, we plug 6 in, and the left side of my equation simplifies to 4 over 32 plus 1 over 32. This is equivalent to the right side of the equation, which simplifies to 5 over 32. Since our result makes a true statement, we can verify that x is equal to 6. Let's try this one last example. Now, remember, the first step is to make sure that we factor our denominators. This will help us determine the least common denominator. Now we have a binomial n minus 6. Let's see if we're lucky to get an n minus 6 factor in this denominator. So let's recall how to factor a trinomial whose leading coefficient is in the quadratic form n squared. Well, since there's only one way to factor n squared, which is n and n, we only have to consider factors of 6 whose sum is negative 7. That would be a negative 1 and a negative 6. So let's also factor our n squared minus 7n plus 6 on this right fraction. And we end up with n minus 1 times n minus 6. Well, in order to determine our LCD, let's look at all the denominators. The n minus 6 times n minus 1 in both fractions on the right side of the equation. However, n minus 6 is missing on the left side of the equation. It is missing a factor that these denominators have. So let's multiply the top and the bottom by the binomial that will create the LCD. Let's actually indicate the LCD right here. The least common denominator is going to be n minus 1 times an n minus 6. So we have to multiply the top and the bottom of this left fraction by an n minus 1. Now that we have like denominators in all of our expressions, we may now cancel this denominator. Cancel. This was canceled because it was factored. This cancels. Now we are left with an n minus 1 on the left side, a 6n minus 12 minus 1 on the right side. Now let's combine like terms and solve. So I have an n minus 1 equals 6n minus 13. Let's finish this off. I'm going to add a 1 to both sides, subtract 6n from both sides. The result is negative 5n equals negative 12. Dividing both sides by negative 5 gives us the final result of 12/5. Again, let's verify that this is indeed our answer. For the sake of time, I have verified that this is indeed our answer. Now that we have seen examples of solving rational equations involving polynomial denominators, this concludes our second day of solving rational equations.
Made with Doodlecast Pro.